Okay, so today we're going to talk about trigonometry. Trigonometry. And trigonometry is the study of triangles and the relationships between their sides and their angles, or the lengths of sides and the measure of their angles. So let's review what we know about right triangles. So let me pull up a right triangle. So here's our right triangle, and we have a right angle, of course. And let's say we have legs, which are 3 and 4. So what we know about a right triangle right now is the Pythagorean theorem. We know a squared plus b squared equals c squared. And we could solve for that third side. We could actually solve any two sides that were given a right triangle. We could always solve for the third side. In particular here now, what I'm looking for is the hypotenuse. The hypotenuse is located across from the 90-degree angle. So let's call this our C. So we're going to substitute in our values, and we're going to solve for C. And we know that C is 5. Okay? All right, and you could try that one on your own if you don't want to believe me there, but we know that 3, 4, 5 is a Pythagorean triple, right? Okay, so what trigonometry does, it allows us, it would actually talks about the ratios that exist between specific sides of the right triangle with respect to a given angle. So let me say that again. What we're going to do with trig, there's 3 ratios, okay? There's the sine ratio, which is abbreviated SIN, the cosine ratio, which is abbreviated COS, and then the tangent ratio, okay? And what these are specific ratios with respect to an angle of the right triangle, an acute angle of the right triangle, and their specific sides. So the sine ratio, let's call our angle here theta. Okay, that's a Greek letter theta. So sine of theta, so with respect to this given acute angle, is the ratio of the opposite side to that given angle over the hypotenuse. Okay, so if I look at sine of theta, I'm going to start at my angle theta. The opposite side would be the 4, and the hypotenuse we solve for, and that's 5. So the ratio between the opposite side to the hypotenuse is 4 to 5. That's called the sine. Okay? The next ratio is cosine. So I'll do that in blue, the cosine of theta. So we're still looking at that same angle, but the ratio of cosine is adjacent side over the hypotenuse. Now, adjacent means that it's the side that's next to the angle. It's the side that's, it's forming that angle theta. So we know that this side here is the hypotenuse. So the hypotenuse cannot be adjacent because hypotenuse is hypotenuse, but we have this side here. This would be our adjacent side, okay? Because we have the opposite, which is over here, and we have our hypotenuse here, and cosine is adjacent, okay? So adjacent over hypotenuse. If I substitute in my lengths, the adjacent side is 3, and the hypotenuse is 5. So the ratio of adjacent to hypotenuse, the cosine of theta, is 3 to 5. And the last ratio that we talk about is tangent. Okay, it's abbreviated TAN. So the tangent of theta. Remember, we're always doing with respect to one of the acute angles. Okay, so the tangent of theta, so I'm looking at theta, tangent is opposite over adjacent. So we already have our sides labeled here, right? So here's our angle theta, and we're going to go opposite side, which we know is 4, over the adjacent side, which we have labeled, would be 3. So the ratio between the opposite side and the adjacent side with respect to angle theta would be 4/3. Okay? And we know it's a lot to remember, this whole sine, cosine, tangent. So we have a little mnemonic. And that, across the board, every teacher knows this one, every math teacher, would be so, ka, toa. So, ka, toa. Okay, I wrote it like this, but I also like writing it like this. So we remember that this is sine, which equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then we have tangent, which is opposite over adjacent. So, ka, toa. Say it with me. So-ga-toa. So-ga-toa. Yay. Okay. So let's try another example, and we'll use the other angle. So I'm still going to use our 3, 4, 5 right triangle. So let me bring up our right triangle again. I'm going to label the sides 3, 4, 5. But now, this was 3, this was 4, this was 5, right? But now I'm going to use the other acute angle of the triangle. So I'm going to just call this x, just because we like x, right? So remember, so, I want to write it like a fraction. Like that, right? So, all right. So now we're going to switch our angle. So let me start with blue this time. Let's do sine. Let's do sine of x, right? So the sine of x. Now sine, as we see here, is opposite over hypotenuse, right? So if this is my angle x, I'm going to go opposite that angle. This is my opposite now. And that's 3 over my hypotenuse. Did I just say adjacent before? I don't know, but we know it's opposite over hypotenuse. Okay, so hypotenuse is across from the right angle. So there's my hypotenuse is 5. So now the sine of x is 3 over 5. If you remember before, our sine was actually 4 over 5. But we switched the angle, so the ratio is going to be different. Okay? All right, let's do the next one. Cosine. Cosine of x. All right? Cosine we see here is adjacent over hypotenuse, right? So adjacent is the side that's next to the angle, but not the hypotenuse, because that's already named, right? So we're going to do the adjacent side. So we're going to label our adjacent side. All the sides are labeled. So adjacent is 4, hypotenuse is 5, the cosine of x is 4 to 5. And then, of course, the last one, our tangent. Ooh, let me do a different color. Let's do red. All right, the tangent of x equals, tangent is opposite over adjacent. Opposite over adjacent. Everything's already labeled, which is really nice. Make sure you are labeling your sides. Opposite is 3, adjacent is 4, the tangent of x is 3/4. Okay? All right. One more example, and we're going to bring in our radicals this time. And I'm actually going to draw this triangle, so it's not always that standard looking right triangle. Right? And I'm going to throw in a radical because I know you guys love radicals. So let's call this side 3, 5, and through the power of the Pythagorean theorem, and watch me, wait for it, see if you could beat me. I bet I'm going to get it before you. That would be the square root of 34. All right, so C is the square root of 34. So let's start by labeling my angles. And actually, you know what? Instead of labeling the angles, I'm going to label the triangle this time. So this is triangle ABC, okay? So now I'm going to let's find the sine of A. So you're looking for angle A, the vertex A. Where is it? Right here. There it is. Ding. Okay, so sine. So, ka-toa. And we could write it. I'm going to write my little reference down here. So, ka-toa. So, sine would be opposite. So, opposite right here. 3 over hypotenuse root 34. Ooh, that's not allowed to happen. Undefined. So, what do? Rationalize. So, through rationalizing, we get 3 root 34 over 34. That's the sine of A. All right, next one. Cosine. Cosine of A. Maybe I'll switch it up on the next one. So the cosine of A, so we're looking at adjacent over our hypotenuse. So adjacent's 5, hypotenuse is root 34. Uh-oh. What do? That's right, we rationalize. There we go. Okay, last one, and I'm going to switch the angle on you, and I'm going to say the tangent of C this time, right? So now we're looking at C. Here's angle C. So tangent is opposite over adjacent. Opposite to C. Now that's different than what I already have marked. So the opposite of C is now 5. This is my blue opposite, so that's 5. And then the adjacent this time is going to be 3, because now I'm looking next to C. So that's 3. So tangent of C is 5 over 3. There we have it. All right, enjoy your practice.